from Codecoon. Codecoon is a product from .de. We want to show you something about the vision we have made, about the stuff we built with Flow, and on what parts we really liked developing with Flow, and on what parts we had a problem, and used some other technologies and built this together with Flow. Yeah, but before that we really want to give a quick start about who we are.
Okay, so welcome from my side as well. My name is Lihs. I'm from Karlsruhe. I studied computer science there for quite a long time, mainly because I worked all the time while studying. So I'm now working at .de for 6 years as a web developer. Not a full stack developer, it's more like the backend stuff, and recently what you might call DevOps stuff or infrastructure. And the last 2 years I had a very intense time with Codecoon. Oh yeah, that's part of me. And I recently joined the TYPO3 server team and was on my first Neos code sprint this last week, and I have to say it was really a great time and I learned a lot there.
I'm Fabian Stein. I'm one of the product owners of one of the Scrum teams at .de. We want to start with why we done this everything. So we want to start with our continuous integration workflow, and we want to show what we understand behind continuous integration and why we used it. From that, then we go to the vision of Codecoon and why we try to build a product out of it. And after that we come to the more technical parts. So how we implemented the single components and how we used Flow in this big context and this complex program. And why we not used Flow for everything, but we try to build everything together with Flow. At the end we will give an outlook of what will happen to Codecoon and why we will go further. If you have any question, we will have a question part behind this whole presentation. In the moment it's a bit difficult if you try to ask between that. So this is actually what we use at .de. We're using GitLab for our Git repositories. We're using Jenkins as a continuous integration server. On our Jenkins we have a commit stage where the commit stage looks for syntax errors by unit tests. So the goal is to get really fast feedback because we have really big projects and not to wait too long till we get this feedback. If the commit stage turns green, we triggers automatically the acceptance stage, and if all acceptance stage tests runs green, we can deploy directly to a staging server where every of our customers has a look on. We can discuss features, we can talk about if it's the way they want or if we need to reinvent on that. And if this is fine, we go to production, and for sure production has its own monitoring infrastructure to see if everything's fine on that. One of the questions is, who's practicing continuous integration of you? Okay. Who thinks that infrastructure of continuous integration is a no-brainer and it's pretty easy to handle? Ah, nice one. Okay, who thinks that the maintenance of the continuous integration structure takes a noticeable amount of time? Ah, some are there. Okay, so we will show you what we think we need for continuous integration infrastructure.
So just to make those people feel better that just raised their hands, I think it takes a noticeable amount of time too. And it's one of the main reasons behind why we came up with Codecoon or want to invent it as a product. So on the slide now you see kind of a workflow that you maybe all go through when you use continuous integration. Those steps you have to run at least once for every project you do, and maybe more often depending on your setup. So the first thing, of course, as a developer we have to set up a develop environment. Either working on a centralized server or working locally or working virtualized. That's most of the time the first step. The second thing is we somehow have to get versioning. I hope no one is working without versioning anymore, no matter whether it's SVN or Git or whatever software you use for that. After that you maybe want to have a demo server or staging, how we call it, and you set up a continuous integration workflow on Jenkins or Travis CI or any other solution. And you somehow have to get your code to the customer, so you set up a deployment to a staging server again or to production. And finally, after running through all those steps, you can start developing your code, and then there goes this cycle. You develop something, you deploy to staging, the customer says, oh, I don't like that, you change it, you deploy it, and finally you can deploy it to production. All those steps are, at least at our company, rather often accompanied by some fixing things. Like, for example, you have to update your GitLab server, you have to update your Jenkins server, something is broken, file permissions, the Apache server is not running as you want it to run. So if you look at your daily workflow, or if you look at my daily workflow, then maybe you come up with some figures like those on the slides. So you spend a noticeable amount of time developing your projects, but there's still a lot of time that you spend for just keeping this infrastructure up and running, which is quite annoying. The idea behind Codecoon is to offer this infrastructure as a service to you. So what we want to make, or want to come through, is you should focus 99% of your daily time on developing on your projects and let this nasty continuous integration stuff do someone else.
So okay, the vision of Codecoon is easy providing continuous integration as a service. It's to enable developers to focus on code again, that they don't need any more infrastructure maintenance and to spend much time as possible on developing. So we want to show you the components of Codecoon as we see it. First we want to start with the developer box. As you might see some slides before, in our continuous integration workflow, it's that the developers at .de develop on their machines. We, in earlier times, we had a big development server in our company, but the more developers working on that, it gets slower and slower, no matter how big this machine is. So we start to virtualize on their machines. It's something we deliver right here, and we delivered at Berlin. So it's a virtual machine you can directly install on your Mac or Windows or something. You can do multiple projects in it, and you have nearly the same environment as our hosting service.
We have exactly the same environment.
Nice. We have, on the other component, we have the continuous integration part. There's mainly the GitLab and the Jenkins in it. For sure, we have even hosting, like staging and production, our servers. Because we want to sell it to you at the last time, we even need an ERP system. This is not programmed from us, but we need to connect to this. And last but not least, we have the Codecoon management portal, which actually is the heart of our product, and it's completely built on Flow, and it's handled all the other things.
So when we started to rewrite the hosting platform 2 years ago, our idea was to make everything from scratch, everything rock solid, and only go public if everything works and we have the full-blown solution for you. Who of you ever developed the product? Okay. And who of you did more or less the same? Okay. So our experience with that approach was not very lucky. And at some point we discovered that it's nearly impossible to do all at once and only go public if we finish this. So we came in contact with what's called the Lean Revolution and read some quite interesting books. We can talk about that later in our booth. The Lean product development says go out as fast as possible and go out with something that's called a minimum viable product. So what's the smallest part of your vision, of your product idea, that maybe brings value to your customers? And after we kind of learned this, we thought about what is the minimal thing that we can take out of this whole big vision, that we can give to other people. They maybe give us some money for it, and they will have a value for that. And we came up with these 3 components that you see here. It's the Codecoon developer box, which was explained by Fabian, the management portal, which kind of manages everything and gives you a smooth experience over all those components, and of course a hosting system. At the moment we only have staging, we don't have production because we don't feel ready yet for actually hosting productive websites in this scenario, but we have a demo server that you can use for free, and the boxes we have outside have a Neos on it, and you click a button and you have it on a staging server. So we think that this is our minimum viable product, and we are again here later on our booth to discuss this, and we will now talk about how we actually implemented this. I will start with the management portal, which is implemented based on Flow. And I would say it's pretty straightforward. We use Flow as the base framework, so we use PHP as a programming language, and we have some pretty simple domain objects on top of that. So what is a domain object in our use, in our scenario? For example, a web server that we want to manage with our portal is a domain object, or a user that has access to this server. Or for example, an Apache server that is running on this server is also modeled in a domain object. And you can imagine that there are quite a few things that have to be coupled together in a special way or orchestrated so that the whole thing works at the end. And to make this, or to put this into a smooth API, we use a lot of service classes on top of that domain model to have easy API calls, for example, Apache server, add new web space, or add new vhost, or stuff like that. And we propagate this to the outside world, again, via services. We use quite a few web services to talk to our management portal, and we use a lot of commands on the command line. Because our problem was we had little money and a lot of things to do, so at some point we decided we have to use all the functionality of the management portal even if we do not have a finished UI yet. And there we came up with the idea of just letting the users use this whole thing via the command line. And of course we have a lot of tests. This was very important. The whole thing integrates a lot of components, and it was I wouldn't say difficult, but interesting to find out how to test this scenario. Unit tests played a not so important role in this, because even in service classes in Flow you have to mock so many things to actually test only the class, what you should do in a unit test, that we soon came up with a lot of functional testing, which is really big fun in Flow. The database mocking and the base classes you get for functional testing make it very easy to test end-to-end, which means you call a service or an API and you test all the way down to the database and back again. We used it, I would say, 80% in our test scenario. And on top of that, we have a few acceptance tests, which means that it's not only the service calls that you test, or the API calls, but you really test from the front end down to the database and back again. And therefore we use Behead. And I can only recommend, if you are still thinking about switching from XBase to Flow, this is one of the big points for Flow, that testing is really fun. So as I told you, we can use a lot of our functionality from the command line. And some of you might wonder, how can we pass arguments on the command line from one call to the other, and how do we get response values and maybe complex structure from one function or command line call to the next command line call? And I don't know whether it was Carsten or Sebastian who came up with this brilliant idea. They helped us a lot. We use JSON on the command line, and we kind of pimped our command controllers in Flow a little so that we can just switch them to output JSON instead of something else. And then we have a small tool called JQ that can parse JSON on the command line, and you can extract certain values out of a JSON structure and pipe this into your next command. And by that we can simply script a lot of functionality in the management portal on the command line by simply piping commands together. And this was also very easy and nice to implement in Flow, because command controllers in Flow are as nice as testing in Flow. I recently looked at command controllers in Symfony and I gave up after 2 hours, so this is something that I think is really a big win if you switch to Flow again. Another requirement for the domain model, which maybe is a little exotic use case, is that we needed to have products that we have in our hosting platform in different versions. So normally if you sell something in a shop, you maybe have some variants of it, but you do not have different logic between different versions of the product. In the hosting environment it's a little different, because if you buy a web hosting package, the content of this package might evolve over time. So that after 1 year of selling this package in a certain combination. You change things and ingredients, but the old package still need to live with their functionality, because you cannot force customers to update all their stuff, so you have to be backwards compatible. And what we did to solve this problem was we have all the products implemented in code rather than only having a line in the database table. So every product in the hosting is actually a class in Flow, and we have different versions for those classes. And the big question was, how can we still work smoothly with those different versions of the same class? And the solution to that also was quite easy in Flow. Sebastian helped us with that. We created a new annotation which we called artifact, a product artifact. And when we put this annotation on such a product class, we can then give this class a version, and the annotation will handle the persistence in the database. So this enables us to have one product or one class in different version at the same time. So the versioning has nothing got to do with Git or version control. It's just multiple implementations of the same products in different versions. This was also something that was quite easy to do in Flow, because the Doctrine object relational mapping framework is just very powerful, and I think after you know a little bit about how it works and how you can extend it, you can make such things very nicely. So after zooming in into the implementation details, we now zoom out a little and talk again about the communication partners of this management portal, because we did not want to re-implement all the functionality in Flow that we needed to actually run our data center with that. So we thought about which components can we use from other suppliers, and it was clear to us quite early that we want to use an infrastructure framework, and we decided to use Chef. Who of you actually knows Chef or works with Chef? Okay. Who hates Chef? Who switched to Ansible? Okay, who uses Puppet? Just I would say Chef wins, okay. Yeah, many different tools now. Who of you knows infrastructure as code as a trend or the technology behind it? Okay, not so many people, so I give a very short introduction to that. The idea is that you can actually code your infrastructure. Code infrastructure. So for example, you can kind of code a service, write it in code, but for example, a web server should provide a service. So there should be an Apache running on it, there should be MySQL running on it, there should be web spaces configured in Apache, there should be databases set up in the database. And the idea of those frameworks, Ansible, Chef, Puppet, whatsoever, is to write this configuration in code, which can be tested, versioned, continuously integrated, put on several stages. So all the benefits from continuous integration in software development can then be transported to infrastructure development. That is one of the ideas behind this. So yeah, we have Chef integrated in our system. We have the continuous integration tools integrated. We have, of course, the web service at some point integrated. And we have the ERP software, because at some point we maybe want to make some money with all of this.
So yeah, that's me in my next life or my last life. After we showed the management portal, we now want to have a look on the boxes as itself. So what was our motivation to work on our machines via a virtual machine? First of all, it's you don't mess up your machine by developing. Yeah. So if you totally break down your machine, it's just a virtual machine, you throw it away, build it new, and because of everything is built up in code, it's pretty easy to re-implement this. The other hand is that you can have multiple environments on different projects, and you can have the same environment on development and production. Even I'm normally the marketing guy, and I do nothing with programming except for some of my private projects, and even my really small private project I did just 2 pages, just break down because I developed it via XAMPP on my Mac, and then I published it to our FreeBSD service, and everything breaks down. So that's pretty handsome if I now develop on our Codecoon boxes. The other hand is that it goes directly with the DevOps mantra, says you build it, you run it, so you can easily say, okay, I be responsible for running my software on my local machine via this virtual machine, and then I can easily go outside and say, okay, this will run. Last but not least, like you see here, you have it with you. At your clients, if you want to show them, or if you are just on a train and the telecom hotspot on the train is not as good as they say it is. So it's pretty nice if you can just work with it without internet and afterwards deploy it to your system.
Okay. So many people asked us and asked us what is actually in the box. This should give you a small impression of what we put in there. It's not only that we made Neos run in there, but we try to put in as many developer tools as you normally need for today's web projects and set them up in such a manner that it's just a matter of usage and not a matter of configuration anymore to work with them. Besides extended LAMP stack, we call it FAM stack because we currently work with FreeBSD. We have the Elasticsearch, Solr, Tomcat, Java stuff in it. So if you work with Elasticsearch on Neos or Solr on TYPO3, you can simply test and develop it in the box rather than needing a server that it's running or not having search in development. We also have some front-end tools, Node.js for example, that triggers some of the build stuff for JavaScript and CSS. And we have some handy debugging tools like xhprof and xdebug. And for xdebug, for example, you just have to press the button in your PHP storm and everything is set up for you. You don't have to bother with setting up it in the development environment.
Yeah. On a meta level, you can get really much benefit out of it. The bigger your projects get, the more it happens that the IT of your customer or the marketing of your customers directly want to go into your project and build something in there by your own, and then it happens that you try to give them an extension and maybe they do something there or whatever. With such a box, you can easily give them this box, they can work at one project together with you, and you can directly integrate them in your continuous integration workflow. On the other hand, for freelancers it's the same. Long time we gave a freelancer just his own notebook from us, and then he has to work on his machine and on the other machine, and it was a bit difficult. Now you can just give this freelancer one of these boxes, he can easily work with that, and he don't have to have access to your customer server, so you don't have a security issue in here. One other thing is on trainings. If you train whatever customers, students, however, you don't need training notebooks anymore. They can just work on their own machine. You don't have spend time to setting up systems to that they can work with it, and they can take this with them, so they can work on everything they build in the training right away. And one other thing is that they can actually work on their products. If you gave them a training notebook, if it's good, they have a Git repository and they can build this on their training notebooks, but most of the time they have to work with a sample site or whatever. If you enable them to work on their machines, it's pretty easy for them to work actually on their product.
So after this short marketing intro, we now come back to the technical parts. How does such a box look on a technical level? Well, we use VirtualBox as a virtualization. I suppose most of you know it. And within this box, we set up the whole environment as we have it on our hosting server. So that's, for example, why we use currently FreeBSD in the box, because we also have FreeBSD on the servers. And our experience is that by having the same setup in development as in production or staging, we can reduce quite a few bugs that normally show up only when you go live in a very early stage. And it's like with all the bugs, there are these nice curves. I try to show it from your direction. It says how much time does it take to detect a bug and how expensive is it. And this curve just goes up and up the longer it takes to detect a bug. And by having this setup, you can be pretty sure that the bug shows up immediately because it won't run in development. And this phrase, worked on my machine, is more or less gone. So that's the idea why we have the same system in the box. The connection of the box to the outside world is made by several protocols. We use Git to ship code from within the box to our Git server. So we use the SSH protocol there. It is secured via an SSH key that is generated for every box put into the box. And so we can make sure that we have an authenticated connection between the box and our Git servers. The other connection is made to the management portal again. I will show you more about this in a minute. And we mount the file contents of the box to your local machine so that you can work with all the tools you are used to. For example, PHP Storm or some Git GUI client or whatever. You have the files locally on your machine and you see them as if they were on your machine. Coming back to the connection between the box and the management portal, at a very early stage we thought about, okay, we just put a separate website inside the box to manage this thing, for example, for trigger a restart of the Apache server, to trigger a commit to Git, or to trigger a deployment from the box to the staging server, or stuff like this. And then we thought, it might be rather confusing if you have the management portal as one website where you can do things, and then you have the second website inside the box. So I think it was again Sebastian who had the idea to connect the box to the management portal directly. And what we do now is we trigger AJAX calls from within the management portal, which runs on our servers, inside the box which runs on your computer. And the technology behind this is called CORS, Cross-Origin Resource Sharing. Normally, browsers do not allow AJAX calls from one domain to another. And in order to enable this, you have to set special headers on your web server on the, let's say, third-party application that you want to integrate. And that's exactly what we do in our box. So we have one website that lets you manage your hosting platform as well as lets you manage your development box. Talking about frameworks and technologies we use, the first idea was to build this management API inside the box also with Flow. Then I wrote a Composer JSON for that, and I ran Composer install, and I had 2 million files in my system. And I thought, 2 million files for 5 web service calls, somehow this doesn't feel good. So I started to look around what other frameworks might fit into this problem. And there were some small PHP frameworks, all of them didn't look like you want to use them. And then a friend said, hey, you have to use Sinatra, it's the right framework for that. And I said, no, I don't want to have Ruby. And then, okay, after searching for quite a while, I came back to Sinatra, and it took me half a day to implement more or less the whole service. And I thought, a framework which I didn't know at all, and a language which I only knew very, very little. Ruby is not my main language. Half a day for setting up a web service with that you can use in production on your own web server, also shipped with this framework. That sounds really nice, and I have to say I kind of fell in love with that for web service. Because it's just so simple that you do not want to use a huge framework for such a small solution. And just to give you some basic ideas of Ruby compared to PHP, this is what you might know as a Composer JSON in the PHP world. And the big difference in some points what the Ruby guys do and what the PHP guys don't do is that the Ruby guys use Ruby for such files. They do not use JSON or XML or YAML. They use Ruby, and they strip Ruby down to some very, very small DSL. In this case, only managing dependencies. But the big benefit you have from that is whenever you leave the set of functionality you have in this framework, you can simply write Ruby code. And you don't have to extend Composer or wait until someone extends Composer for your stuff like that. And that's something which I really liked a lot, to have a very lightweight DSL for a problem, but still be able to extend it in whatever way you like by simply writing Ruby code. And for me, that's, for example, the big benefit of Chef or Puppet when it comes to Ansible. Because in Ansible you have this YAML thing again, and you have to write classes and stuff for extending functionality, and here you can simply write some lines of Ruby code. Okay, talked a long time. Going a little faster through that now. That is all you have to implement to have a web service function in Sinatra, a few lines. The name of the function more or less gives you the routing. and everything you return will be immediately returned to the service caller. That's all the configuration you need in Ruby to set up your own web server, even with SSL in our case. That's the command to run the web server, and then you are done with your own service. Runs independently from Apache, was perfect for our use case because we at some point want to manage Apache with that, and restarting Apache with the software that runs on Apache is not a good idea. That's all the files for the web service. It's very compact. Yeah. Try it out, I can recommend it. So, after I showed you the components of the box, we can now talk about how we built the box. Who of you is using Vagrant? Yeah, great, like that. We also use Vagrant, and we use the same chef recipes for provisioning our box in Vagrant as we use on our service. For those of you who do not know Vagrant, you can think about Vagrant as something like this. It's a remote control, and it controls your virtual box or Amazon or how's it called, Fusion, VMware, whatever virtualization software you use, you can kind of remote control it with Vagrant, and it just makes it very convenient to work with provisioning in Vagrant and stuff like that. So we take the chef cookbooks, put them in the Vagrant box, run them there, have our environment there, export what's called an OVA file, it's just a format for a virtual machine. And then we use some magic scripts written by us to put this in a Mac or Windows installer. It's no magic at all, just some shell scripts, and after that you have this nice experience double-clicking the installer, waiting, and then having Neos opened on your screen. We talked a lot about the management portal and the development boxes now. One of the last parts, I think I have to hurry up, is our web servers. Web servers are simply chef nodes in our platform, which means they register on a chef server, take their configuration from there, and provision themselves. This looks something like that. So instead of mounting the cookbooks into the Vagrant box, what we did before, we now upload them to a chef server. It kind of manages cookbooks and other configurations for servers. And we have a client on the server machines that connects to this server, and the concept of chef is that they pull their configuration from there, and then they run on the machine, and after that, hopefully the machine looks like you wrote in the code you put to the chef server. No magic. There's one important thing missing. The connection between the management portal and this chef server is very simple. We just write some JSON strings out of the management portal and upload them to the chef server as what is called a data bag. And the data bag is just kind of a configuration in Chef. So if you ask yourself, how can they manage infrastructure or servers from a Flow application, the answer is very simple, by writing JSON. And the magic happens in the cookbooks that read those JSON strings and do things with them. So in the JSON string, for example, we want to have a web space with this file host listening on this domain, and this user rights or user permissions and stuff like that. And the chef cookbooks then know how to read this configuration and provision your infrastructure.